Astronomy Lab, Section PH 2330.02. This is the presentation of our solar system project. Our mission in the syllabus was to explore different worlds, to small scale represent the sizes of the planets with household food, to do what no astronomy student has ever done before. This is the Sun, the star at the center of our solar system. We call it Sol, and it has been anthropomorphized in so many cultures, and it's always been around for humankind to observe. It's a gigantic ball of fusion reaction that superheats the plasma of the Sun to around 15 million degrees Kelvin at the core to about 5,800 degrees Kelvin at the surface. It is 109 times the diameter of Earth, and when in relation to this project is a 100-foot tall building, also known as Grafton Hall.
We begin with the terrestrial planets.
And compared to the Sun in our solar system, which is Grafton Hall, 100-foot building, here's the grapefruit. This represents Mercury, 4.3 inches. Mercury is 2.6 times smaller than the size of the Earth. Mercury is the smallest planet in the solar system. It rotates the Sun once every 88 Earth days. Mercury's surface temperature ranges from 90 to 700 Kelvin, which is equal to negative 183 degrees Celsius to 427 degrees Celsius.
The next planet we have in our solar system is Venus. We can represent Venus with this lovely cake right here. Our model right there is 10.44 inches across, compared to our Sun object, which was Grafton Hall, which is about 100 feet tall. The Sun's much bigger. Venus is about near Earth size, just ever so slightly smaller. It's got sulfuric acid clouds that cover its whole atmosphere, which is about 90% carbon dioxide. The surface temperature is about 860 degrees, and it has about 90 times the atmospheric pressure of Earth. It goes around the Sun once every 243 days and has a revolution every 223 days. It's one of the brightest objects in the sky.
The third rock from the Sun, with no reference to the show, is Earth, the planet that we all live on. So that makes it pretty important to me. Earth, in this representation, is 10.44 inches across, or roughly the size of this basketball. Compared to the 100-foot Grafton Hall, it's pretty inconsequential. Earth is the best planet because we live on it, and it's the only planet that we know of that we could live on. It has one moon, it has an iron core, a thick, dense atmosphere made of mostly water vapor and beautiful, beautiful oxygen and nitrogen.
Next in the line of planets we have Mars, which is represented by this cantaloupe right here, approximately 5.8 inches. Mars is the fourth planet in the solar system, in between Earth and Jupiter. Its orbital period is 1.881 Earth years. It has a temperature of about negative 20 to negative 40 degrees Fahrenheit. And its diameter is only 5.31 of Earth's diameter, but its mass is only 0.107 of the Earth's, which means it is much less dense than the Earth is. It also has 2 moons.
And now to the jovial planets.
Here we are at the Plymouth State rugby field with the goalpost, which is 10 feet from there to there. This represents Jupiter. Jupiter is the largest planet in our solar system. It takes about 16 Earths to go across the diameter of Jupiter. Jupiter was discovered in 1610 by Galileo. It's the brightest planet in the sky and has a rotational period around the Sun of 11.6 Earth years. It's a jovial planet, a giant gas planet, which has lots of rings, though not quite as visible as Saturn's. It has a differential rotation from the polar regions to the equatorial regions, and has a giant red spot that's a big storm that's been raging on there since we discovered it.
Hi, this is our Saturn, represented here by an 8'7" U-Haul trailer. Saturn's the second largest planet in the solar system. It's Jovian. It has a large ring structure. It's mostly made up of hydrogen and helium, metallic hydrogen at its core. 1 year on Saturn is roughly 29.5 years on Earth. The great pictures from the Cassini spacecraft as it flew by a few years ago came from it. It would float in water because it has less than 1 of density relating to water. And 18 Earths would fit across it at its diameter. Hello again. We're here at the rugby field at Plymouth State University looking at this big rock with a meter stick on top of it. This rock represents Uranus, the second to last planet in our solar system. It is the third largest in the solar system. It was discovered in 1781, and it is the last thing in the solar system that you can see without a telescope. There are very small rings around it, just like all the other Jovian planets. Uranus has a strange thing about it, that it might have seasons. Over the course of its orbit around the Sun, just like Earth does, it actually has different temperature changes. 8 Earths would fit across it. 1 year on Uranus is approximately 84 Earth years. And compared to the other Jovians, it is the coldest of the Jovian planets. And ironically depicted here by a rock, even though it's a non-rocky planet. Hi, this is Neptune, represented right now by roughly a 3-foot 6-inch manhole cover, going from the concrete to the concrete on the end. Neptune is the 8th planet in the solar system, and because of Pluto's demise, it is now the last planet. It's slightly bigger than Uranus. It takes 7 Earths to go across it. It has a 164-year orbit, roughly, which means that we are about to see it finally complete its first orbit since it was discovered in the late 1800s. It has a differential rotational atmosphere, just like Jupiter and some of the other Jovians. And like Jupiter, it has a great dark spot on it, which is a massive disturbance the size of Earth.
And last but not least, Pluto, the Plutoid. For our models, we can represent Pluto as this beer can right here. Pluto is, for our model, would be 2.04 inches across. It's about 5.5 times smaller than Earth, and it goes around the Sun about every 292 years. It was discovered in 1930 in Flagstaff, Arizona, and until recently was considered a planet. It's now considered a minor planet or a Plutoid, much to the dismay of a lot of people. But it's still there.
Vi sitter här i vänten och spelar lite Dota och pushar på och smeker med motståndet vi leker. Vi sitter här i vänten och spelar lite Dota och springer runt och creepar och motståndet vi slipar. Vi sitter här i vänten och spelar lite Dota och pushar på och smeker med motståndet vi leker. Vi sitter här i vänten